So the next speakers to come up are Mark Ryland and Alyona Lamash. And Mark and I've known Mark for quite a long time, and I couldn't remember what I met you before, Mark, and I just was talking to you then. And I remember Mark was involved very heavily in the Turquoise project, one of the leaders in moving into the alternative exchange and execution space. And I was working in the back end of that at Citibank, so that's when I saw your name, I remember it. So Mark now is strategic advisor to Exactpro, has about 20 plus years experience in the industry.
And still here.
And still here. And Alyona is head of risk management practice at Exactpro.
Great, well, I'm very, very pleased to see you here. I thought you were gone by now, but you come back to hear about something completely different, which is about testing, or QA and testing. We're using those as alternative terms. They're not the same thing. So the presupposition for this talk is that you're trying to make a large systems change of a post-trade system, and I guess hopefully you've all been involved. Can we turn that down just a little bit? We've all been involved in, I don't think many of you have been involved in such initiatives from time to time. If you are, you'll know that how difficult large projects can be to achieve, and one aspect of that is the QA or testing, and usually the QA testing is a part of the problem. It's sort of a bit slow, it costs a lot of money, you don't get very good results, and everyone gets very frustrated with it. But there's an alternative, and the alternative is that the QA testing is one of the parts of the project that actually helps you get it done quickly and effectively. And that's really what we'd like to talk about, how that can be possible. And hopefully you'll get some insight into that. Now, if you're, okay, so just a little bit about our company. Oh, what happened there? I pressed the wrong one. It's this one. So we're a pretty small company. We've focused on testing, that's both functional and non-functional testing of systems that process wholesale financial instruments. We've grown from 5 years to be over 250 people. We are a US company, but actually all the work takes place in Russia, where we have 4 centers. Most of our work is to do with testing trading platforms for exchanges and brokers, but we have significant post-trade experience as well, which is why we're here today. We've done quite a lot of work with the London Stock Exchange Group with their clearing initiatives. We worked with OEKB, which was, I guess, one of the main reasons for coming here today. Our tools are used in T2S. We're currently doing a large project for Singapore, and we're involved with LME Clear as well. We already talked about us. So we're going to divide our talk into 2 parts. I'll do the first part and Alyona will do the second part. Firstly, we're talking about generic challenges that apply to testing large systems, whether they're post-trade or not. And then secondly, we're going to talk about specific challenges which affect post-trade initiatives. And we're going to use examples from clearing, because that's the projects that we're most engaged in right now. So, beginning with the generic stuff. Making testing for large projects is a challenge to get it right. I've already mentioned the things that can go wrong, but we're going to try and keep our talk fairly short as it's late in the day. So without going through these specifically, basically what you're looking for is your testing to be comprehensive. You're looking for your testing to be fast in terms of executing and getting the results back. You're looking for the results to come out being accurately, and you're looking for flexibility to deal with changes which occur in the project, and you're looking for your testing team to actually make a contribution to the whole team, not just be a drag holding it back. But this is easy to say, but it's not so easy to do, so we'll try and give some insight into how it can be done. So I'll skip over this. So the first thing is that the large projects, are done by people. Pretty obvious, but it's a very important factor. And the QA team is just one part of that. And typically the QA part of the project team doesn't start at the beginning, it sort of starts somewhere later on. We favour getting started just as soon as possible to make the best overall contribution. But we're working with people. Each of these functions is staffed with people. And my observation of all the live projects I've ever worked on is that there are some people in the project team who actually are the stars, the people who actually take ownership, who understand the detail, who work with each other creatively and productively. And those are the people that really carry the lead. They carry the project forward. And then other people who are not stars, who are participating but not really driving it. And so what you see is that the stars are the people who really make the pace in the project and get it done. And perhaps it seems absolutely ridiculous to suggest that the testing team staff could be in the star category or driving the pace, but really we think that is possible, and we are able to achieve that by the approaches that we take, which I'll just detail a bit more now. So there are really just three types of elements that go into this, we think. Firstly, you need highly capable people in your testing team. Really smart, bright people who are enthusiastic, proactive, who understand the domain in detail, and who are creative and flexible. Then you need to have test processes. A lot of test management is about process. It's about turning requirements into test cases. It's about storing them in repositories. It's being able to execute them, select the ones for executing, get them done. You need all that kind of process. You need, obviously, to have the right quality in your test cases, and you need to have the right processes for executing and reporting, and also for when there are problems found, because that's the objective of testing, is to find problems, to be able to report those clearly with great detail, so that they go right to the right person who needs that information, and they can work with it straight away. And then final part of the picture here is that you need the right technology. Technology means managing the test environments that you have. That means all the inputs and outputs, all the data that goes in those environments, being able to start and stop them effectively, knowing how they work. But also, you need the right tools, special test tools. In our industry, there aren't the greatest test tools that you can just buy off the shelf. So really, you want to be able to build tools which are just right for the particular task that you've got in mind. And I've drawn this as a polar diagram because you could go through the process of, on any given project, looking at your testing team, measuring them with this polar diagram and asking yourself the question, are you really getting what you are really to have from them or not? These are some of our people. They are a young, enthusiastic, dynamic bunch, so we think that they do measure up, and there are some people in the room who've used our services, so hopefully they'll speak to that over coffee. The next point I want to make is there's actually 2 points on this slide. The first point is that your testing is an independent measure of what you've achieved. When you're building a building, it's pretty easy to see where you've got to, because the floors go up, the steel girders go in, the windows go on. You can see. In an IT project, it's not like that. You can say you've met a goal, but in fact you haven't. And what you really need is the independence and objectivity of the testing team to really measure what's actually there, and then feedback in a fearless fashion, because it's unequivocal, fact-based, clear feedback. And that feedback is incredibly important to the effectiveness of the project. The second point I'm trying to make here is that all projects are basically doing the one arrow, where you're starting from a requirement and turning it into code. Sorry, that's where the requirements come in. The project team are doing the two arrow. They're creating code which meets the end requirement from the original user. Typically, the test team comes in on the 3A arrow here. Oh, I've got one of these. This is what your typical test team does, but that's not really good enough, because what you really want is a test team who understands enough about this total context that they can give feedback not just based on the specs that the business analysts produce, but based on things that the business analysts might have missed. And you can do that if you've worked on similar projects before. You can bring additional insight into the feedback. So independence is a real key aspect of your test team, as well as all the other things I mentioned just now. And if you put all that together, what you get is a set of behaviours in your overall team, which are quite different from the behaviours that you'd otherwise notice. Your developers, be they in-house developers or vendor developers, they really start to work harder now because they realise that anything that they provide, any code that they deliver that doesn't work, it's going to come back really quickly. They work harder, and also once problems have been found, they really respond to that feedback. Your analysts and designers are getting much better evidence themselves as to what's wrong, so they can vote with it. And your sponsors and project managers can have confidence in the system because the testing is great. And they also then will experience the thing going to live with fewer problems, and that means saving money. That means, as we all know, fixing problems once they're live costs a lot more money, and actually the testing team will save money during the project as well, because the whole project will be done more quickly than it otherwise would. So that's the end of the generic bit.
And we're now moving from the specific challenges, specific for trade systems. And I'm going first to put you into the context. So what are the systems we are dealing with? We have here a number of external parties, external systems, which are connected, which contribute to clearing systems or will use the outputs or enter the inputs, such as markets, participants of different kinds with different type of connections. There are settlement systems and payment systems, so we're currently talking about clearing systems, and that's why connection to these two. And the market data providers and the interventions from the operation start. Inside of the system, there are also several features which I would like you to draw attention in. So the first one, this is reference data. For clearing system, reference data setup is very complex thing, and usually requires high accuracy, and most of the processes heavily depend on the reference data setup. For example, trading but an enrichment of trades is heavily dependent on reference data. A small, tiny errors in the reference data setup might result in the dramatic changes, dramatic diversity from the actual result to expected result. Another key feature is risk management. As it was a couple of times described today by other speakers, risk management is one of the core processes in the clearing system, and it's usually quite complex area which requires specific knowledge, large resource usage, and skills. And another feature is the schedule, and I'm going to move to the next slide to show you to bring you to this context in more detail. So every day, the clearing system, there are several processes which run in the clearing system every day, such as trade upload, computations, market computations. There are settlement sessions, collateral uploads, reporting, and some other processes. They are repeated every single day with usually predefined order, and sometimes even at the predefined times. That processes are dependent on each other. And in the same time, so this means that to test this properly, we need also to have this test across days within these repeatedly happening processes. And another point is that there are several inputs which are done into the system, and they are kept in the system afterwards. They are kept across all these days of the test scenario. So strict schedule, dependence on the data which is entered and kept across days makes additional challenge. And Still setting a context, I'm going to describe a couple of the test scenarios which need to be executed if we are delivering a clearing system. First one is collateral deficit. To run this scenario, we require trades which will actually invoke initial margin call. We need to check these margin computations. We also need to simulate input from participants which deliver collateral to cover the risk exposure by CCP. And we need to have additional computations with the regulated collateral and delivered collateral. Another example is the delivery default, where we have multiple day scenario with the first day started with the trade upload and settlement which happen only with the next days. So, for example, 2+3 now and 2+2 after the 6th of October. And we, in this scenario, need to simulate different inputs from settlement systems where one participant fails on these positions, another participant settles, and so on. We need to check further processes which happen after settlement failures, such as calculation of penalties, buy-in, cash settlement, and this scenario might last several days due to the nature of the process. And another example is the corporate action, when we have to deal with several days again, because we need to put trade positions and to make sure that corporate actions will be applied only to positions which are eligible for these corporate actions. And we also need to check that further computations, such as risk computations for the processes such as settlement run, will take all these positions, all the new and original positions properly. So I'm now finishing with the setting the context and moving to the challenges which we would like to discuss. So there could be much more challenges in the quality assurance of clearing systems, but we come up with six of them. And I'm going to discuss each of them in the further slides with the solutions. So the first one is testing of complex multi-steps scenarios. As we've just seen on the examples, there is a need to test multi-steps scenarios. There is a need to run some tests across days, and there could be also a need to run several test scenarios at the same time. This actually the challenge which is faced by the QA team. And our solution is to use the automated test tool, which allows to run several scenarios, organize the steps in batches, and align the test schedule with the system schedule. For example, there are several scenarios, and all of them have something in common. There are blue-colored boxes, which represent global steps, which are related to these system steps, such as margin computation or collateral revelation or settlement run. And there are another steps which are present for some scenarios and not present for others. So they may be relevant for only specific cases, not relevant for others. And the system, the test tool allows us to execute each scenario and each step of all of these scenarios in predefined order to align this order with the events in the clearing system and to organize them in the batches. So actually there are 3 examples, but we're usually dealing with much more number of test scenarios. So that's how we currently dealing with our project. And by the way, this test tool is also used by T2S project team. I'm now moving to the next challenge with this limited availability compatibility of the downstream and upstream systems. So in the initial picture, there were all of these external parties which should be connected to the trading systems, but in real test life they are all gone. There is no such system because they don't usually available for the full time, or the availability is very limited. So what we need to do is to put simulation in all of these interfaces, and we created a simulator for all such systems, and the test harness controller, which allows to control both simulators and execution of the test cases. And next one is the challenge, which is related to the fact that most of endpoints are accessible via API. So there is actually no user graphical interface which can be used by a user and which can be in a human readable format. So to deal with this challenge, we use test tool where user defines the input in the user readable format, in the human readable format. The system transforms this input into the request, which can be the tool transfers this input into the request, which can be understood by the system interfaces. And then it receives the response, which also can be transferred into the human readable format and even validated against the expected result. Another challenge is reference data, which I was describing a couple of slides ago, which is quite complex in the clearing systems. So it requires appropriate setup, it requires maintenance, and it's usually required to move reference data from one test environment to another. So for this purpose, we implemented data management tools which allow us to meet these goals. And in addition, the same tools can be used for data migration in production, as well as test process. Complexity of risk calculation algorithms is one of the challenges as well, because as I already said, that risk management is a key area and requires maybe much more effort than others. This is complex due to several facts. First is that mathematical concepts which are underlying the algorithms, underlying the ideas, could be quite complex. It's usually a high amount of data which should be used to test it appropriately. So there are several solutions. One is to implement the model which is based on the simplified assumptions, but replicates the algorithms and replicate the calculations which are done by the system, and compare the actual results from the system on the test to the expected test results computed by the model. And another solution is to define the reliable set of tests from the system from the very early version, and define this baseline from regression, compare it with the results that come from the system on the test. And number 6 is regression cycle, which is an important thing, as we usually need to run a substantial number of test scenarios, and usually we need to run it within the appropriate time frame. So the approach is to start with the test cases, with definition of test scenarios and cases. Create test tools which are capable of running these test cases with the system. Automate the test cases with the tool. Apply control to the test environment, because we need to control all inputs and make sure that the state of the environment is appropriate for the regression with the predefined conditions. And finally, run the automated regression. Internally, we call it the big button. So we have discussed all these challenges separately, but they actually fit together into a holistic, integrated automated test scenario, test solution.
And we use the H word again. Okay, and basically our contention is that if you get that generic stuff right and the specific stuff right, put that together, then you've got a great QA team who will really help you get your post-trade system implemented ahead of time, below budget, with high quality. Thank you.
Thanks, Alan. Thank you very much. Any questions? I've got a question for the audience, actually, as well as you, Marcus. I don't know that much about CCPs when you peel it back and look at the technology. Do they run solutions that they buy off the shelf, or do they all have their own solutions? And then they internally operate those, do you know?
There's quite a lot of bought ones and some built ones as well. So the leading bought ones these days are Sonova have an excellent one, and Millennium have an excellent one.
Okay, thanks. Okay, thanks very much.